How do you get started with rapid prototyping for wearable computing? A good starting point is the book chapter by Jessica Rajko in the book that we advertised in the introductory session on wearable enhanced learning. Jessica describes here a prototyping board with a small selection of sensors that are fun to work with and a standard microcontroller. This will help you to understand how Arduino and e-textile development works. But if you decide to go further, there's a wide range of control boards and sensors you can choose from. Here on the left, you see the famous LilyPad that has been designed in particular for its ability to integrate well into textiles. But there are others you can choose from. A short list is here in front of you, and their properties, whether they're washable, whether they have then connectors for analog and digital, and whether they have Wi-Fi capability or Bluetooth. On the bottom, you can see the ESP32 with an integrated mini display that makes it easier to debug. That's the one that we have been using in our own work. Every microcontroller is operated by an Arduino sketch. A sketch consists of three parts. At the beginning, you would find definitions and data structures, as well as additional functions that are executed then later. And then there are two main methods. Method one is the setup method, which is executed when the controller boots. And the second one is the loop, which is executed multiple times per second, depending on how much processing you do and how quickly the loop can actually be executed. With regards to sensors, here you see a selection that may be useful for you to get started with. Fun to work with are cheap or a little bit more expensive MPUs. You see an example here on the bottom left, the famous MPU 9265 or MPU 9250, which allows you to capture movement, acceleration, orientation of the component. So if you integrate that little chip here and breadboard into a sleeve, for example, you can sense where the forearm is moving. Or on the right, you can see an integratable battery. On the top right, you can see a pulse frequency measure with the ear clip. This is an example of our own work. This is the harness we developed in WeKit, an e-textile that went through several iterations of design. This is the naked electronic component. So you can see in the middle the microcontroller and then the connecting wires to all the different sensors. This can then be integrated in different form factors. You can see on the top one design study with a battery pack and a holder for the microcontroller, as well as in various other locations, as you see on the right, holders for the different sensors. On the bottom, you can see a different design study, helping us to refine the gear, the e-textile, to its final version. The final version then consisted of motors and an IMU on the spine and an IMU on the chest, as well as additional sensors for biophysical signals. In the final version, we decided to go for a simple harness to integrate it, which makes it easier to test, as we were running out to test that with around 400 people. Here you can see the harness in action. What it allowed us to do, you can see depicted here. So on the left, you can see a person wearing the harness, following the instructions that have previously been recorded with the harness. On the right, you can see what the person sees, which is a little ghost representation of an expert walking around this Mars rover. The ghost representation moves with the IMU unit of the HoloLens the person is wearing, as well as the forearm movement is syndicated using the sensors on